Hello and welcome to today's video. Today we're going to be doing 314 binary tree vertical order traversal. So given the root of a binary tree, we want to figure out the vertical order traversal of its nodes values. And if those two nodes are in the same row and column, the order should be from left to right. Okay, this makes sense. So we're given an example here, a chart, and we have here we want to return 9, then 3, 15, then 20, then 7. And then we also want to have the 4, 9, 3, 0, 1, 8, 7 here. Okay, I'm starting to get the hint of it now. We do 4, 2, 5, 1, 10, 9, 6, 3, and then 11. Okay, so now that I have this kind of in my head, an idea which I'm actually having is we could have we could BFS, right? So we have a BFS, and then as we go down for every single level, we keep track of how far we have gone from the root. So at this point, we want to go from, like, let's say for example we're at 3, we initialize the BFS, and we move to the right, and then we add 1, and then we move to the to the left, and then we subtract 1, and then we add that to like the level order traversal. And like to the BFS, and as you keep iterating through, you can keep adding and adding and adding, and then eventually what can happen is you can go ahead and then add the specific column that it's in, right? You want to figure out what the column is, and then you can add that to a hash map, and then with that hash map we can then go ahead and return the elements of that hash map afterwards from left to the right. Now, because we want to turn from left to the right, we probably, while we're doing this, we want to keep track of the minimum and the maximum value for the elements in this binary tree. So, for example, this is -1, the -1 column, right? Because it's -1 from the root. This one is 1 and 2. This one is 2 columns ahead. So we know because of this that we want to iterate from -1 to 2 and go through every single element in the hash map, which is populated with these column values, and then we're going to go ahead and return our final value. So if that kind of makes sense, I'll go ahead and begin implementing it now. So we'll go ahead and do a BFS. We'll do a first of all, we'll have a hash map, and we'll have this equal to this, and then we want to go for every single v, or we want to do like a BFS, so we want to initialize a queue actually, so we have a queue here, and then while queue exists, what we want to do is for I in range length of queue, we want to do cur dot pop left, and then from here what we want to do is we want to do if cur dot left, we want to append it, right? So and we want this to be if there is a current value. So if there is a current value, then we want to do a cur.append, or a q.append cur.left. If the cur exists, right? If cur.left, we want to do a q.append cur.left, and then we also want to append the current column that it's in. So you want to do the current column. We'll actually go ahead and we'll have to initialize this with the root first. So we'll have to do like roots and then the current column that it's in, which is 0. And then from here, what we can do is we can do the current on the left, and then the current column. So we'll have this column, so it goes in here, and then we can do current column call -1. Likewise, we want to do here if cur.write q.append cur.write call +1. So from here we have the left with call -1 and the right with the call +1, and then from here what we want to do is we want to do the actual check and put it into the hash map itself. So if cur exists, what we want to do is we want to do hash map with the current column, and we want to we want this to be initialized with a default value, so we'll do default dict, and then from collections import default dict. And then from here, what we're going to do, once we've initialized the default dict, we're going to append the left and the right, and then we're going to have hashmap call dot append. We want this to be defaulted with a list, and we'll have this dot append the current value which is being added. So we want to do cur dot val. And then after that, we also want to keep track of the mins and the maxes. So we want to do mini maxi equals 0, 0. And from here, we want to do mini is equal to the min of the call and the mini. Maxi is equal to the max of the call and the maxi. So from here, we'll do that. We'll append it to the value. And then I'm going to see if cur left, we're going to append it onto the left. And same thing with the right. So we're going to add that to the queue, and we're going to move on for our next iteration. After all of this is done, what we're going to do is we're going to loop through for I in range length, or actually from range mini, and then maxi plus 1, because we want to iterate through for every single element from here. 0 maxi plus 1. Because we want it to be inclusive, we want to go ahead and append that to our final resulting array. So res equals this, and we will do res dot append hmap I. And then from here, what we want to do is return our final result at the very end. So just to walk through this over again, it's kind of a dry run. We'll go ahead and start off with these values. So we start off with 3. We add 3 to the it starts off with 3 and 0 to the queue. Next, we check to see. We pop it. Does it exist? I mean, like for every single element in the level, which is currently 1, we pop from the left. It's a queue. We do this 3 and 0, and we think, okay, what's the mini? It's gonna be 0, and what's the maxi? It's gonna be 0. Is there a left? Yes. We add a 9, right? So this becomes 9 and -1, and is there another value? Yeah, well, it becomes 20 and 1. So the next iteration is going to have the rest of like the elements, and it's going to keep on going, so on and so forth, adding the 9, adding to the hash map. The hash map is going to add column 0, column 0 is going to be equal to the 3, and then eventually what's going to happen is hash map at 9, or like the hash map at -1, -1 is going to be equal to 9. So it's going to keep adding this, and it's going to keep on appending, and then from there it's going to loop through from the range 0 to whatever you're at, right? Until you're at like 0 and then 1, and then you go all so on and so forth. We want to do this, and then we want to append this as part of a final result. So if we go ahead and run this now, oh, sorry, just a quick typo here. You want to pop from the queue, and we want to do this. Oh yeah, sorry, we need to initialize this as a deck. That's another thing I forgot to do, because we want to pop it from the left. So we'll initialize like this, a deck, and then we'll have a list, and then the root 0 here. Run this again, accepted, and then let's go submit this, see if it works. Okay, we're missing one test case. Oh shoot, we forgot the root case where there's nothing. In that case, well, we want to do, if there isn't a root, we want to just return nothing, right? So if not root, then we just return an empty one, because in this case we don't actually want to add anything to the deck. So that's what we want our final value to be. We run this, submit, and there we are. We're accepted and we're good to go. So the time complexity of this is going to be O of n, where all of the elements are like you're gonna have to iterate through all of the elements in here BFS style. So that's gonna be O of n, and the O of the space complexity is going to be O of n in the worst case, because you're going through every single element from here, right? So you're going to be adding everything. So it's going to be O of n in the worst case, because let's say like we have a tree that's just like a straight like 3, 9, 4, and 8, 7. That's going to be like O of n worst case, because that's gonna, or like O of n worst case, because it's going to like move as a function of n. But I guess a better way of saying it would be that it would be, the space would be O of like the current level of the thing, because yeah, actually, yeah, it'll be O of n space, I'm pretty sure. Yeah. Yeah, it should be O of n space, worst case, space complexity. I might provide like a clarification down in the video after I do some further research. But yeah, thank you guys for watching.